Hey, how's it going? Today we're going to talk about oceans and lakes and ponds, perhaps. And also, where did your water come from? Probably everywhere. More likely, it was drank by dinosaurs or Egyptians and so forth. I just drank gladiators' water from their sweat. Let's begin. Our planet is an ocean world and we are water people, of course. Precisely 70% of the surface area of Earth is oceans, which contains 97% of Earth's water. About 55% of our bodies consist of water. Where did our water originally come from, you ask? Probably first arrived here on asteroids and icy comets from the icy outer reaches of the solar system. But even if that's true, that's only the last piece of the jigsaw, not like Saw. Did it exist in space before the sun was born? Yes, some researchers say, says new research published in Nature, which reveals that water has been found around a young star for the first time. Scientists found at least 1,000 to 200 times the amount of water in all of Earth's oceans around a protostar, a very young star, in the early stages of its evolution, 1,305 light years distance in the constellation Orion, or Orion, up to you. So you're drinking dino pee and spit. That's fantastic and neato. One factor in establishing when water appeared on Earth is that water is continuously beyond lost in space. H2O molecules in the atmosphere are broken up in photosynthesis or photolysis, and the resulting free hydrogen atoms can sometimes escape Earth's gravitational pull. When the Earth was young and less massive, water would have been lost in space more easily. Lighter elements like hydrogen and helium are expected to leak from the atmosphere continuously. But isotope ratios are heavier noble gases in the modern atmosphere suggests that even the heavier elements in the early atmosphere were subject to many losses, unfortunately. In particular, xenon, or xenon, is used for calculations of water loss over time. Not only is it notable gas, and therefore is it not removed from the atmosphere through chemical reactions with other elements, but comparisons between the abundance of its 9 stable isotopes in the modern atmosphere reveal that the Earth lost at least one ocean of water early in its history. Unfortunately, between the Hayden and the Echoan time. Any water on Earth during the latter part of this time frame accelerated would have been distributed by the moon formation impact, which was about 4.5 billion years ago. That's a long time, which likely vaporized much of Earth's crust and upper mantle and created a rock vapor of atmosphere around the young planet. How cute. The rock vapor would have condensed within 2,000 years or so, leaving behind hot violets, which probably resulted in a majority carbon dioxide atmosphere with a hydrogen and water vapor. It's quite tasty, to say the least. Afterward, liquid water oceans may have existed despite the surface temperature of about 446 degrees Fahrenheit due to the increased atmospheric pressure of the CO2 atmosphere. As the cooling continued, most CO2 was removed from the atmosphere by subjection and dissolution in ocean's water. But levels only went crazier as time went on. New surface and mantle cycles appeared. The pillow basket on the seafloor near Hawaii was formed when magma extruded underwater. Have you been to Hawaii? I have not. I love Jurassic Park. Anyway, let's move on. Other, much older pillow basket formations provided evidence for larger bodies of water long ago in Earth's history. Geological evidence also helps contain this idea and time frame of liquid water existing on Earth. A sample of pillow basket, or a type of rock formed during an underwater eruption, was recovered from Isla Greenstone Belt and proves evidence that water existed on Earth 3.8 billion years ago. Neat. In Quebec, Canada, rocks dated at 3.8 billion years old by one study and 4.28 billion years old by another show evidence of preservation of water that ages as well. If oceans existed earlier than this, any geological evidence has yet to be discovered, unfortunately, which may be because such potential evidence has been destroyed by geological processes like crustal recycling. More recently, in August of 2020, researchers reported that water to fill the oceans may have always been on the Earth since the beginning of planet's formation, which is quite fascinating. You're more likely to drink dino pee, and I love that about the Earth. Determining the age of water molecules may sound peculiar since they all appear to have the same composition. 2 hydrogen atoms and 1 oxygen atom. However, researchers develop deeper into the element that may make up these molecules. In all, it began with scientists attempting to determine the age of the solar system itself. They focused on studying the levels of hydrogen and also interstellar ice. I know, neat. Deuterium is a heavy hydrogen isotope that contains an additional neutron. This isotope can only form in extremely cold temperatures, such as those found in vacuum of space, not like the vacuum in your cupboard. Next, scientists created a computer model to simulate the conditions present during the formation of the Milky Way, which is quite neat. The aim was to investigate whether the sun could have generated enough energy to produce amazing amount of levels observed in interstellar ice and some water on Earth. The results indicated that the sun alone could not generate sufficient amounts of deuterium to explain the observed levels of water. Also, scientists concluded that the majority of water containing this heavy hydrogen must have originated from space, predating the formation of our solar system. Wow. The presence of heavy hydrogen in a significant portion of Earth's water does not have a direct impact on human beings. It has always been the present and will continue to be so. However, these findings have significant implications for other scientific reasons. According to the research involved in the study, as well as other experts commenting on the findings, this discovery has far-reaching implications for our search for extraterrestrial life, or ET. Water is a crucial resource of evolution of life on the planet, of course. It gives us life and other life forms a way of being as well. It is plausible that it is also contained the creation of other planets within the Milky Way and beyond. This suggests that the likelihood of finding more life in the universe has increased as well, because there's many planets such as Titan or maybe Pluto that has an atmosphere, that has water as well, may have life, such as lobsters. How much would you pay for a lobster on Pluto or Titan? I'd probably pay $200. Anyway, let me know down in the comments below what you think of drinking water from dinosaurs' pee. I find it quite fascinating and lovely. Anyway, have a great one. Bye-bye.